Okay, class. Question number 4 for this week is testing us about Kirchhoff law, basically. Okay, so before we go to the question, okay, so this is a figure. As you can see from the figure, we have more than one EMF or the battery. Okay, so figure 5 shows a circuit containing 3 batteries and 3 resistors. Calculate the value of current I1, I2, I3. So from the figure, we can see this is your I1, this is your I2, and this is I3. Okay, to solve this question, we are applying Kirchhoff laws. Okay, that's the only way we have. So let us recall, to solve Kirchhoff law, we have to have, okay, we have to have 3D and 3E. Okay, you have to have 3 directions, okay, and also 3 equations. So only after that you can solve your circuit, okay, to get the current I1, I2, and I3. Okay, so we start with direction. You're supposed to have first, you're supposed to have direction of I. Okay, so direction of I is already drawn for us, and then direction of EMF, okay, it's supposed to be from negative to positive, okay, negative to positive, negative to positive, okay. And last one, we want to draw the direction of loop. Okay, so it's up to you. You can draw clockwise or anti-clockwise. So mine will be both. um, so mine will be for loop number 1 anti-clockwise, okay, and for loop number 2 clockwise. So that's mine. Okay, so to get the 3 equations, the first one we are applying, okay, we're trying to get the junction law. So the first equation is, okay, the first equation E1 is from junction first rule. So that is, if we refer at point, let's say we choose point at junction P. So at junction P, current I1 is entering the junction, plus I2 is also entering the junction, and I3 is leaving the junction. Okay, so this is your first equation. And then to get the equation of E2, okay, second equation, so we choose one of the loops. So we have loop, let's say we choose loop 1 first, and then okay, and then we are applying junction second law, summation of EMF is equal to summation of IR. Okay, so if we refer, we have to always compare the direction. So for the first EMF, 12 volt EMF, this one, okay, if we are referring this one, so the direction of okay, so the direction of loop and the direction of EMF is the same, so it's supposed to be positive. Okay, it's supposed to be positive. So it's going to be 12. And if we compare the second EMF here, okay, so the direction is again equal to the direction of loop. So again, it is positive. All right. And we have 2 resistor. We have resistor here, resistor 8 ohm resistor, and the current flowing in the resistor is I1. So I1 times 8, okay, 8 I1. And the direction is opposite, so it's supposed to be negative. And we have the 4 ohm resistor, and it is having positive, similar direction with the direction of loop. So for I2, okay, so simply simplifying the equation. Okay, then you're supposed to get 30 of negative 8i1 plus 4i2. So this is your second equation. Next, the third equation is from loop number 2. Okay, so loop number 2, again we are applying the second Kirchhoff law. Okay, so we do the same. We have to always compare direction of EMF with the direction of loop. So for this, okay, EMF, okay, it has the similar direction with the direction of loop. So it's supposed to be positive 18. And if we compare with this EMF, the direction with direction of loop, so it's supposed to be negative. Okay, we have resistor 6. Okay, resistor 6 with I3 flowing. Resistor 6 I3 flowing here with similar direction with the direction of loop. So positive, supposed to be positive I3, and one more is we have 4i2. Again, we have positive. So again, simplifying the equation, 16 equal to 6i3 plus 4i2. Then you'll have your third equation. Okay. Okay, now what we do is we rearrange our equations so that all of the equations, so that we can have a nice arrangement of I1, I2, and I3. Okay, so that it can help you to press your calculator easily to include. Okay, now we rearrange the equation, okay, so that I1, I2, and I3 will be in a good array. Then you can have a proper use of calculation. Okay, now we want to calculate the value of I1, I2, and I3 in using the calculator. So we rearrange the equation so that I1 comes first, followed by I2 and I3 minus I3. So this is your first equation. Your second equation, we have negative 8i1 plus 4i2 plus 0i3, okay, equal to, so we put 0 as if we have I3 there. Then last one is we don't have I1, then we just put 0i1 plus 4i2 plus 6i3 equal to 16, the third equation. Okay, so using a calculator, you can use the function in the calculator of the equations. Then finally, you'll get your value of I1. It's supposed to be 2.27 ampere, I2 2.69 ampere, I3 0.69 ampere.